All right, so 9-4 inscribed angles. The first thing I have here for you on your sheet, and you don't have this picture inside the circle, so you need to add the blue things that are on here to your paper. So we've got an inscribed angle definition, an angle whose vertex is on the circle, so you might want to highlight that, whose vertex is on the circle and whose sides each contain chords of the circle. And so I've put here, you can see the dot there where you would put your center point of E, and then the vertex of this angle ABC, B is on the circle, and then AB and BC are chords of the circle, and they create this inscribed angle. In addition to the inscribed angle, remember how we had a central angle that had an arc associated with it? Well, so does the inscribed angle. So look at the ends of the angles. It goes from A, here's the angle, to C. If you trace from A to C, keeping a viewpoint of the vertex, so going in this direction, the arc from A, and you might want to add this point D, because isn't this a major arc? And we name major arcs with 3 letters. So I added this point D here, and so this particular inscribed angle creates a major arc of ADC. So we have what's called an intercepted arc, and it's always created by the endpoints of the sides of that angle. And you might want to add here major arc ADC. So there's an example of what we're working with. So a lot of theorems start to come to play from all this. Theorem 9-4. If an angle is inscribed in a circle, then the measure of the angle, the degrees out of 360, equals 1/2 the measure of its intercepted arc. So think about this. Does the opening of the angle look bigger or smaller than this arc? Smaller. This angle, which is smaller, is half of whatever this arc is. So if this arc turned out to be, oh, I don't know, 300 degrees, then what this theorem is saying is we have discovered that the measure of this angle here is going to be half of that 300 degrees, which is 150 degrees. Does that make sense? What was the degree measure of an intercepted arc with a central angle? Was it different than half of the intercepted arc? What if I had an arc from here to here, and I said that this was 100 degrees? What would the intercepted arc be? 100 degrees. So with central angles, the intercepted arc is exactly the same as the angle measure itself. But with an inscribed angle, meaning the vertex is on the circle, the measure of the angle itself is half of that intercepted arc. You have to know that. And if you look at your Ames reference sheet, isn't that what this is saying? So here's a vertex on the circle. Here's your chords. So the intercepted arc is AC. This is saying that the measure of angle X, X is right there in the angle spot, is half of the measure of arc AC. So this is actually on your Ames reference sheet, but you have to realize that it's there, and you have to know what it's talking about. All right, so then let's look at some examples. If I were you, I would have highlighted this part, by the way. We'll use that a lot. So in circle Q, segment AC is a diameter. That's important that they tell you that, because that tells me that from A through B to C is a semicircle, and it's 180 degrees, or from A through D to C is also another semicircle, it's 180 degrees. You might benefit from copying the picture down on your paper tonight and using a highlighter, different colored highlighters if you have them, to see the sides of the angle, and so you can see what the arc is that intercepts it. Because as you can see in this picture, there's a lot of inscribed angles in here, because I have 1, 2, 3, 4, 5 vertices on the circle. So I can have up to possibly 5 angles here. So that's a lot of stuff going on. So the first question says, or the first part of the directions say, the measure of arc CD is 68 degrees. So I'm going to go from C to D and put 68 degrees here. And then the measure of arc BE, all the way from B to E. So I think I'll use a different color. So from B to E is 96 degrees. That's all that they gave us. The question says find the measure of angle ABC. So from A to B to C. B is my vertex. So if I'm going from A to B to C, the arc that intercepts is from A through D to C. So it'd be nice if I knew that arc. We'll get to that. The other thing that they want us to find is the measure of angle BDE, CED, and the measure of arc AD. So here's how we go about it. They gave us two very important pieces of information. They must have given us the 68 degrees and the 96 degrees for a reason. Let's start with the 68 degrees. So if 68 is from C to D, is there an angle, an inscribed angle that intercepts that arc? Here's the endpoints. So follow D, and what's the path to get to C? Wouldn't it be this right here? Can't I find the measure of angle CBD? This angle right here? Right? This is the intercepted arc. So if this is 68 degrees, what's this angle according to our theorem? What's half of 68? 34. So first off, the measure of angle CBD is equal to 1/2 of 68 degrees, which is 34 degrees. So I'm going to put a 34 degrees here. And then the other piece of information that they gave us was this 96 degrees from B all the way to E. So again, you want to find the inscribed angle that's associated with that intercepted arc. So if the endpoints are B and E, take B and find the path to get to E. Wouldn't that be from B to C to E? Wouldn't it be this path right here? Doesn't that intercept that arc? So I would put an arc mark here, all the way here. So those two angles here together. What's half of 96? What is it? 48. So that gives us 48 degrees. So I don't know if that's helpful, but at least that's what I can tell from those angles. So the measure of angle BCE is equal to half of 96 degrees, which is equal to 48 degrees. So let's look at this first angle ABC. That didn't quite help us with either of those, right? What do you notice about the endpoints of angle ABC, this one that I highlighted in pink? Because that's the first one that they want us to find. What about the endpoints A and C? What's this arc here? Isn't this the intercepted arc? From A all the way to D to C. What kind of an arc is that? What's this going through here? It's the diameter, right? So what kind of an arc is this? A semicircle. Don't you know the degrees of the semicircle? So if the semicircle is 180 degrees, what's the measure of angle ABC? ABC. What's the measure of this whole angle? What's half of 180? 90, right? So step 3, the measure of angle ABC is equal to half of the semicircle, 180 degrees, which is 90 degrees. So this is the first item that they wanted us to find, is this one right there. The second one, do you see how this can get complicated with all your drawing on that? Okay, the second one that they want us to find is BDE. So from B to D to E. Look at what's intercepted by B to D to E. Was there another path from B to E rather than this one that we took before? From B to D to E, isn't this the same intercepted arc as we did here? Okay, So wouldn't it be the same measure? So look at number 4. If I'm going from B to D to E, the arc is BE. So the measure of angle BDE is equal to half of its intercepted arc. So its intercepted arc is BE, which is 96 degrees, which is 48 degrees. What can you conclude about these two right here? What can you conclude about angle BCE and BDE? That they're equal. So what about inscribed angles that intercept the same arc? What can you say about their degrees? They're congruent. So you're going to see another theorem come up here that if you have two inscribed angles that intercept the same arc, they are going to be congruent measures. All right, so we've got 2 out of the way, we've got 2 more. Let's find CED. What about CED? What arc does it intercept? I'm losing my voice. Doesn't it intercept CD just like this one up here did? Isn't that the same situation as these two? So if I look at angle CED, so follow it with your fingers, angle CED intercepts the same arc CD, which is 68 degrees. So this is another set of inscribed angles that intercept the same arc. They should be the same measure. So CDE is half of its intercepted arc of 68, and half of 68 is 34 degrees. So again, aren't those equal? So there's 3 out of the way. The last one, AD, the measure of arc AD. So I need to go from here all the way to here. What do I know about A all the way to C? So don't forget what you learned before. What's A to C? A semicircle, so it's 180 degrees. Don't we know from C to D? Don't we know from C to D? How much is from C to D? 68. So how do I find from A to D? Subtract the 2, right? So that's going to equal 180 degrees, that semicircle, minus the 68 degrees, which is what we learned previously. And what are we going to get? What do we get? 112. So I can ask you arc measures, I can ask you angle measures. So that's a fairly complicated picture. If you go slowly and you keep tracing, some of you saw it immediately. Some of you, you're going to have to keep retracing with your fingers because you're going to constantly lose it. Literally, it's going to fly out of your brain. So keep tracing, or use multiple colors of markers so that you can see what, or you can redraw the picture a couple of times, one for each angle, until you can see what intercepts what. Do what works best for you. So then look at this down here. If 2 inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Didn't we just see that in that picture? Okay, so there's your official theorem on that. Flip it. Theorem 9.6, you got to draw a picture. So you can see the dots. They're calling to you to connect. So draw a diameter and then connect these points. Label them A, B, C, and the center is E. And then I want you to put another point, about here, and call that D as in dog. So this is kind of the same theorem as if you have an inscribed angle, that it's half the intercepted arc, only it's real specific to a diameter. this says if an inscribed angle of a circle intercepts a semicircle. So here's our angle from here to here, noting that AC is a diameter. It intercepts this arc, ABC. Anytime an inscribed angle intercepts a semicircle, the measure of that angle itself is going to be a right angle or 90 degrees. It's half of 180 is 90 degrees. And so they just want to re-emphasize that to you, so that the measure of angle ABC is 1/2 of the semicircle, which is 90 degrees. So look at example 2. Now I have to remind you that you may not go by the looks of the picture. They're always deceiving. So you have a picture down here in example 2. In circle X, the measure of angle 4 is 7x plus 3. So this angle right here, 7x plus 3. And the measure of angle 5 is 7x plus 3. What does that tell you about those two angles? What does that tell you about these two angles? They're equal. So what does that tell you about the sides opposite them? They're equal also. Now, what if I tried to set 7x plus 3 equal to 7x plus 3? Am I going to be able to find x? What's going to happen? They're going to cancel out. You're going to get an identity. Okay, you'll get all real solutions. So we can't use that to solve for x, but I'll show you how we can in a minute. Then it goes on to say that the measure of angle 1 is 5x. So this one right here is 5x. Find the measure of angle 1, 2, 4, and 5. Now they haven't specifically stated this, but doesn't this straight line go through the center of the circle? What can we assume about this line here? That it's a diameter. Now, having said that, this vertex here probably isn't directly vertical to this vertex here as is stated. You cannot assume that if these are equal, that these are equal also. The only thing I can assume is that these are equal. But watch. If this is a diameter and this is an inscribed angle and that's my intercepted arc, what's the measure of angle 6? Isn't it 90 degrees? Just based upon the theorem above. So I know that angle 6 is right angle. So number 1, the measure of angle 6 is equal to half of 180 degrees, which makes it 90 degrees. If angle 4 and 5 are congruent, what can you conclude about them? If the measure of angle 4 is equal to the measure of angle 5, because they both have the same expression, what can you conclude about the measure of angle 4 and the measure of angle 5? What's they equal? If this is 90, what do those have to be? Isn't this a 45, 45, 90 triangle? So if that's true, then their measures are 45 degrees each. Now can I find the value of x? Yes or no? Yeah. So now I can take 7x, which that marker does not work. Then I can take 7x plus 3 and set it equal to 45. Solve. Subtract your 3. 7x is equal to 42. And divide by 7. What does x equal? 6. How can I use that? How is that beneficial? Yeah, I can use it to find angle 1. And isn't that one of the angles that I need to find? So I've found 4, I found 5. Now I can find 1. So that's my third step. So step 3, bless you, the measure of angle 1 is equal to 5 times, and I'm going to put the 6 in here, and the 6 came from there. So isn't that equal to 30 degrees? Now all that's left is angle 2. Well, what's the measure of angle 3? the endpoints on this also intercept a diameter. So what's this intercepted arc here? That's a semicircle too, isn't it? So isn't this also a right angle here at 3? And if this is 30 degrees, what's angle 2? Yeah, the measure of angle 2 is equal to 90 minus 30 degrees, which is equal to 60 degrees. Now, does the picture show that? The picture specifically was drawn to try to lure you into thinking that, okay, if those are equal, those are equal. So you'd have 45, 45, 45, 45. So you can't always go based upon what the picture looks like. All right, so then theorem 9.7, our last theorem of the day, says if a quadrilateral, how many sides is that? 4, is inscribed in a circle, then its opposite angles are supplementary. So quadrilateral inscribed, opposite angles are supplementary. What's supplementary mean? They add up to 180 degrees. So then, for example, 3, I have a picture of a quadrilateral inscribed in a circle. So circle C has quadrilateral QRST. If the measure of angle T is 95 degrees, so I wrote that in there for you, and the measure of angle S is 100 degrees. Find the measure of Q and R. Well, what is the opposite angle to S? It's opposite angle. Opposite angle. Q. So doesn't that mean that Q is 100 degrees? So number 1, if angle S equals 100 degrees, then the measure of angle Q is equal to 100 degrees. So there's one of them. Question. Oh, thanks. There's my brain. You're right, it's not. He says supplementary, so what should it be? 80 degrees, sorry, thank you. So then this is equal to 180 minus 100, which is equal to the 80 degrees. Sorry, you're right. All right, so then what are we going to do for angle T? If angle T is equal to 95 degrees, then what's the measure of angle R? What's 180 minus 95? 85 degrees. Think of a square. What should the interior angles of a quadrilateral add up to? 90 plus 90 plus 90 plus 90 is 360. If these two add up to 180, and these two add up to 180, don't they add up to 360? Okay? So it must work. Now, the other thing that I have for you is a study guide, so let's look at that. So, let's see how you do on this on your own. So what's nice about the study guide is it's got all of our theorems kind of summarized up top. And it has a picture of an inscribed angle that's intercepted arc. What I want you to be interested in is this down here. So I want you to first name the intercepted arc, name this inscribed angle, any inscribed angle, and name the central angle, and then stop of this picture here. So you do that on your own. Make sure that you're using proper notation. Right, so stop there, and we're going to collectively see, because there's more than one answer to some of these. Wouldn't you agree that the intercepted arc for angle RTS is arc RS? And if you begin to look at it, what are the endpoints of this angle? R and S. So that would be the endpoints of my arc. So if I have a minor arc that it intercepts, you've already got the answer without looking at the picture. If I've got a major arc that it intercepts, then you do need to find another point to put in there because you name those major arcs with 3 letters. All right, so let's look at the inscribed angles. Raise your hand, give me some inscribed angles, we'll see if we agree with them, because there's more than one answer. So obviously this one is an inscribed angle, so we're not going to write that one down. What's another one? Nobody wants to say anything. Shall I just start to call out names? Cole, what about an inscribed angle?
RVS.
Is the vertex that he chose on the circle? Yes. So angle RVS is agreeable. Morley, how about you? RT what? RTV. So she chose this one here. Very good. So angle RTV. What else? There's more. Jua, how about you? SVT, yep. Megan, how about you? Which is this one here? Yep. Carlos, how about you? RSV. So you get the idea, right? There's still a couple more, but that's good enough. All right, name a central angle. There's only one choice. What's your center? P. Now, I cannot name a central angle TPV because are there any chords connecting T and P or P and B? No. So if P is my center, what's the central angle? There's only one. RPS, right? In this particular picture, there's only one. There could be more than one in a different picture. All right, so then let's look at these sections here. So in circle P, so it's still that circle up there, they're giving you some arc measures. So we've got an arc measure for SV right here of 86 degrees. And angle RPS is 110. So trace that from R to P to S. What kind of an angle is that? What kind of angle? Central angle. So intercepted arc for a central angle has what kind of measure? Same measure, different? It's the same. So that means that arc RS is also 110 degrees. We don't have a diameter here, but we do know from R to S is 110, from S to V is 86, and we can find from R to V. How would we find from R to V? What's the whole circle worth? 360. So wouldn't you subtract 110 plus 86 from 360, and then you can find from R to V. So our trouble right now is finding specifically RT or TV. So look what they gave you there. So the first question is find the measure of angle PRS. So from P to R to S. Is that right? P to R to S. Oh, interesting. How are we going to find that one? It's this angle right here. That angle is part of a what? A triangle. What kind of triangle is that? Why do you know it's isosceles? What are these two things right here? Right eyes. So if that's isosceles and we know that that's 110, how much is left over for these two angles, which are the base angles? So there's 70 left over, then cut it in half. Don't you have 35 here and 35 there? So that's how we get the 35 degrees. So they're using your prior knowledge. Then we want the measure of RT, arc RT. So RT is from here to here. So RT is intercepted by this angle here, from here to here. I don't know this arc, do I? I do know this angle here, but I don't know this little piece of that angle there yet. So we might have to hold off on RT until we could at least find TV, right? Do I have any way to find TV yet? Yes or no? Are there perhaps two angles that intercept this arc, RT? We see this one. Is there a different one? What about this arc here? We don't know that one either, do we? Why don't you get into some groups? I'm going to give you about 5 minutes. I want you to stare at that. There's one little piece that you have to see. It has to fall into place for you to find all of them. There's one piece that you've got to find, either something to find this arc or something to find that arc. Mind you, we've got little triangles here, here, here. That might help. Or find another inscribed angle that intercepts a similar arc. So U4 are working together. U4 are working together. On top, U3 are working together. U4, U3, and then U3 are working together. On the top, I know it's what's here. It's so sleepy. U4 right here are working together. U4 right here are working together. U4 together, U5 are working together. So turn and talk. I want you to figure out the missing piece. 4 heads are better than 1. Is it the Don't give up. Talk, talk, talk. Some of you are not turning and talking to each other.
I don't know how that would help.
Has anybody figured it out yet? Do you see something inscribed in the circle other than an angle? What's that? What? It's not a hat. What is this? What polygon is this? It's a quadrilateral, right? Let me take, what do you know about quadrilaterals inscribed in a polygon? Opposite angles are supplementary. So let me take away this right now. Take away that. Look at that angle there. Don't you know both arcs to that angle? So this is an inscribed angle, right? So this angle right here intercepts this arc, which is 110 plus 86, which is 196. This whole intercepted arc. So what's that angle there? How do you find it? Inscribed angles are what to their intercepted arcs? Same or half. So we're going to divide this by 2. So 2 goes in here 98 times. So wouldn't you say that this whole angle here is 98 degrees? Right? So it's opposite angle because we're trying to find arc RT, correct? Its opposite angle is over here. What's 180 minus 98? 82 degrees. So now let me take this away. That 82 degrees, isn't this the intercepted arc for that 82 degree angle? It intercepts this whole arc here. That's smaller than this arc. So what's the arc measure? If this is half of this. Double. So what's 82 times 2? 164. So this is 164 from here to here. So arc RV, which did they ask us for RV? So now we know that RV is 164. Huh. So now I have to find just RT. Now couldn't we have gotten the 164 by just subtracting this from 360? Right? Alright, so how else are we going to do that? Another piece to your puzzle. Keep talking. So we found part of it. Chat amongst your groups. Don't wait for me. Now you got another piece of the puzzle. When you think you come up with a solution, let me know, but keep chatting. Austin, what do you think? Say that again, because my ears are plugged. But why? Not just because you're correct, but why? How do you know that SV and RT are equal to each other? You're guessing. It is correct, but you're guessing. How can you prove that? So keep going. Chat, chat, chat.
When I read up there, there's some angles are
Okay, so you got, this is, where'd you get the 45 from?
43.
Oh, is that 43?
Yeah, because
doesn't this intercept the 110? So wouldn't that be half of 110, which is 55? So that would be 55.
I thought it was because of S is the intercepted angle.
Okay, that's the Q is not on the circle. But you can say that RBS is half of 110, which makes that 35. So we can say that. Same thing here, that one's 45 over here. Right there. Can we use that though to find Q? You're on You're almost there. If you can find this angle here, if you can find any angle around Q, that would work. But for right now, it's going to be tough. Well, actually, you could do it. Are you guys ready? So, Brianna brought this to light. So look at this. Oh, what was this again? 160, what was it? 164. All right, so from here to here, what's this angle if it intercepts the arc of 110? What's this angle right here? 55 degrees, isn't it half of 110? Right? Then, what's this angle here? Intercepts the same arc. What's its angle measure? 55 degrees. Okay. So that gets me this angle here and that angle there. If I can find any one of these angles around here, that might be good. What about this angle here? This one from here to here, so I can find that angle measure there. What's its intercepted arc? What does that add up to? So 196. And then we already looked at that before, right? What's half of 196? What is it? 98, right? So if this whole angle is 98 and that's 55, subtract 55 from it, what do you get? So isn't this angle here 43 degrees? Couldn't you have also gotten that angle by looking at, see the 86 here? See the inscribed angle here? So that's 43. And if that's 55, how are you going to find, this angle here? So we have one angle in each of those triangles. Can we come up with one more angle in order to prove that that angle that I've got shown here is also 43 degrees from here to here? So it's one more piece to your puzzle. See if you can find another angle either in this little triangle here, right here, or in this triangle here. Based upon probably these two known angles there. One more angle and you got it. So keep going. Don't forget your quadrilateral. Do you remember what this whole angle was over here? Did we ever figure it out? What was it? 182 from here to here? So this right here was 98, right? And we found out what this one was. Did we find out what these were?
For angle SRT, I got 43.
SRT 43?
SRV.
Oh, SRV. You're correct. That's 43. But what's this whole angle here at R for that quadrilateral? Because that might help you. All right, so I'm going to stop you here. One more piece to your puzzle. I want you to figure that out, and I want you to come with the answer tomorrow. I don't know it. I want you to figure it out because that's what you're going to have to do on tonight.